June 3rd, 1944, 0247 hours, 1,200 feet. Above Salisbury Plain, England. Private First Class. Danny Crawford's reserve parachute failed to deploy at 0247 hours and 37 seconds, 3 days before D-Day, 200 feet above the ground during a nighttime training jump that was supposed to prepare the 101st Airborne Division for the largest airborne assault in history. Crawford's main parachute had malfunctioned. A cigarette roll, the riggers called it, when the canopy wrapped around itself instead of deploying properly, creating a twisted column of silk that provided zero drag and turned a controlled descent into a ballistic fall at 120 miles per hour toward Earth that was getting closer at a rate of 176 feet per second. Crawford pulled his reserve ripcord at 900 feet, felt the pilot chute extract, felt the deployment bag separate from the pack, and then felt nothing because the reserve canopy's deployment spring, the small coil spring that was supposed to push the canopy clear of the deployment bag and allow it to inflate, had corroded from 3 years of storage in damp English hangars and failed to extend properly. Crawford hit the ground 7.4 seconds later at 118 miles per hour, impacted feet first in soft mud that absorbed maybe 20% of the kinetic energy, and died instantly from catastrophic skeletal trauma, shattered pelvis, fractured spine in 4 places, ruptured aorta, massive internal bleeding. He was 22 years old, from Bakersfield, California, scheduled to jump into Normandy in 72 hours as part of Operation Neptune, and he died not from German bullets or artillery, but from a 12-cent spring that had rusted in storage and failed to deploy a reserve parachute that was supposed to save his life when his main chute malfunctioned. Staff Sergeant Robert Bobby Mason watched Crawford die from 400 feet away, descending under his own functional parachute, unable to do anything except witness a fellow paratrooper accelerate past him in free fall and impact the ground with a sound Mason would hear in his nightmares for the next 45 years. Mason was a parachute rigger for the 101st Airborne, responsible for packing and maintaining the T-5 parachutes that every paratrooper in the division depended on for survival. He'd packed Crawford's reserve chute 6 days earlier, had inspected the deployment spring visually, had seen no obvious corrosion, had certified the equipment as airworthy according to Army Technical Manual TM 10-16701. But TM 10-1671 didn't require destructive testing of deployment springs. It didn't mandate replacement schedules based on storage conditions. It didn't account for the fact that English humidity averaged 80% year-round and that steel springs stored in canvas packs for 3 years in damp hangars would corrode internally, where visual inspection couldn't detect it. The manual said, "Inspect springs for visible rust or deformation. If none present, spring is serviceable." Crawford's deployment spring had looked fine externally. Internally, corrosion had weakened the coil to 40% of rated strength, not enough to extend fully against the deployment bag's fabric resistance. Mason landed, ran to Crawford's body, found no pulse, no breathing, no signs of life. He performed CPR anyway, because the alternative was standing there doing nothing, while a man who'd been alive 30 seconds ago lay dead from equipment failure. After 5 minutes, medics arrived and pronounced Crawford dead at the scene. After 10 minutes, Captain Richard Walsh from Division G4 arrived and started asking questions about who'd packed the reserve chute and why the deployment spring had failed and whether other parachutes had the same defect. Mason told him Crawford's reserve had been packed according to procedure. Spring had passed visual inspection. No reason to suspect failure. But the spring had failed anyway, and if one spring could corrode without showing external signs, other springs could too. The 101st Airborne Division had 6,220 paratroopers preparing for D-Day. Every paratrooper carried a reserve parachute with a deployment spring. If the failure rate was even 1%, one spring in 100 failing from undetected corrosion, that meant 64 paratroopers would die from reserve malfunctions during Operation Neptune, and those deaths would occur during the actual combat jump when there was no time for second chances or additional attempts. Captain Walsh made the decision that would either save hundreds of lives or delay D-Day. Mason, I want you to inspect every reserve parachute in the division. Check every deployment spring. If you find corrosion, flag it. If you find springs that look questionable, flag them. I need a report on my desk by 800 hours tomorrow morning with failure rates and recommendations. Mason spent the next 19 hours inspecting deployment springs and reserve parachutes across the 101st Airborne Division. What he found was catastrophic. Of 6,420 reserve parachutes inspected, 847 showed internal spring corrosion that couldn't be detected by visual inspection, but that significantly reduced spring force. Most of those springs would still function, barely, but 127 springs were corroded severely enough that Mason estimated they had less than 50% chance of deploying a reserve canopy under load. That's 127 paratroopers, 2% of the division, carrying reserve parachutes that were essentially non-functional, equipment that would fail exactly when it was needed most, during the few seconds between main chute malfunction and ground impact. But there was a worse problem. The Army didn't have 847 replacement deployment springs available in England. The springs were manufactured in the United States, shipped across the Atlantic, distributed through supply chains that took weeks to process requisitions. Getting 847 replacement springs from a factory in Pennsylvania to paratroopers in England would take minimum 18 days. D-Day was scheduled for June 5th, later postponed to June 6th, which was 72 hours away. There was no time to order replacements, no spare inventory in theater, no backup plan for what to do when critical parachute components failed en masse 3 days before the largest airborne operation in history. Mason had been a mechanic before the war, worked for a machine shop in Detroit that fabricated custom springs for automotive suspensions and industrial equipment. He understood spring mechanics, how coil diameter affected force, how wire gauge influenced durability, how heat treatment determined strength. And he knew that deployment springs weren't complicated. They were simple compression springs, 1.2 inches long, 0.6 inches diameter, made from music wire rated to 200,000 psi tensile strength. Total cost per spring from military suppliers, 12 cents. Total complexity, approximately 0. Any competent machinist with a wire coiling machine and heat treatment furnace could fabricate replacement springs in a few hours. But Mason didn't have access to wire coiling machines or heat treatment furnaces. He had access to a parachute rigger facility with sewing machines, fabric cutters, and basic hand tools. He had no authorization to modify military equipment. He had 72 hours before 6,420 paratroopers would jump into Normandy carrying reserve parachutes that had a 2% catastrophic failure rate. And he had the memory of watching Danny Crawford hit the ground at 118 miles per hour because a 12-cent spring had rusted in storage. He started by examining failed springs under a magnifying glass, documenting exactly where corrosion had weakened the coils. The pattern was consistent. Internal surfaces showed rust that had progressed inward from moisture penetration, reducing wire diameter by 10 to 15% in the most affected areas. The springs weren't completely destroyed. They could still compress and extend, but they'd lost 40–60% of their rated force, which meant they couldn't overcome the resistance of deployment bags packed with silk canopies. What Mason needed was either replacement springs or a way to reinforce existing springs so they could generate sufficient force despite corrosion. Replacement was impossible given time constraints. Reinforcement was theoretically possible but not documented in any technical manual. Mason had never heard of anyone reinforcing a compression spring. But he'd also never heard of 127 paratroopers jumping into combat with equipment that had 50% failure rates. So maybe it was time to try things that weren't documented in technical manuals. The concept was simple. If a single corroded spring couldn't generate enough force, use 2 springs in series. Double the coils, double the force. The problem was fitting 2 springs into a deployment mechanism designed for 1. Standard T5 reserve parachute containers had spring housings that were exactly 1.2 inches deep, the length of 1 deployment spring. Installing 2 springs would require 2.4 inches of space, which didn't exist, unless Mason redesigned the spring housing, which would violate every regulation about modifying parachute components without engineering approval, which would probably get him court-martialed if it didn't work, which would definitely save lives if it did work. He started with 1 reserve parachute, serial number 73A4291. The next parachute scheduled for use by Private Williams from Company A, 502nd Parachute Infantry Regiment. Mason disassembled the spring housing, which was a cylindrical aluminum assembly that held the deployment spring and connected to the pilot chute through a cable system. The housing was designed to be removed and replaced as a complete unit, not modified or altered. Mason modified it anyway, using a drill press to extend the housing depth from 1.2 inches to 2.5 inches, then installing 2 deployment springs in series, one on top of the other, creating combined coil stacks that generated approximately 180% of single spring force. He tested the modification using a spring compression tester, measuring force output at various compression lengths. The reinforced spring assembly generated 14.2 pounds of force at full compression compared to 7.8 pounds for a standard single spring. That was enough to overcome deployment bag resistance and ensure canopy extraction, even if 1 spring was partially corroded. But testing in a lab didn't prove the modification would work during an actual jump. Mason needed to test it under real conditions. Fine 200 feet altitude, terminal velocity freefall, deployment loads that simulated main chute malfunction, which meant someone had to jump with the modified reserve and deliberately cut away their main parachute to force reserve deployment. And since Mason had designed the modification and knew exactly how it worked and couldn't ask anyone else to risk their life testing equipment that might kill them, he'd have to do the test jump himself. Captain Walsh approved the test jump with exactly 4 words. If it works, proceed. If it doesn't, you're dead. So court-martial is irrelevant. Mason made the jump at 0347 hours on June 4th, 1944, 43 hours before D-Day, 24 hours after Danny Crawford's death. He exited the C-47 transport at 1,200 feet, deployed his main parachute normally, confirmed canopy inflation, then executed a cutaway procedure, releasing the main canopy and going into freefall at 120 miles per hour. At 800 feet, he pulled the reserve ripcord. The modified dual-spring deployment system activated, pushed the canopy clear of the deployment bag, and inflated properly. Mason descended normally and landed without injury. The modification worked. 2 springs in series provided enough force to deploy reserve canopies reliably even when individual springs were partially corroded. Total cost per modification: 12 cents for an additional spring plus 20 minutes of labor to extend the spring housing. Total improvement in reliability: estimated 98% reduction in deployment failures for corroded springs. But Mason had 847 reserve parachutes that needed modification and 40 hours remaining before the division started loading onto C-47s for the flight to Normandy. Even working continuously, one rigger couldn't modify 847 parachutes in 40 hours. He needed help. He needed other riggers who could follow his procedures. He needed authorization to implement an unauthorized modification that violated equipment specifications, but that would save approximately 127 lives during D-Day operations. Captain Walsh issued the authorization at 0800 hours on June 4th. Sergeant Mason is authorized to modify reserve parachute deployment systems on all 101st Airborne Division equipment using dual-spring reinforcement technique. All available riggers are assigned to assist. Completion deadline: 2,000 hours, June 5th. Failure to complete will result in operational delay of D-Day airborne operations. Mason and 23 other riggers worked for 36 consecutive hours, modifying 847 reserve parachutes using the dual-spring system. They worked in shifts, fabricated extension housings, installed additional springs, tested each modification for proper function. By 1847 hours on June 5th, 1 hour and 13 minutes before deadline, they'd completed the final parachute. Every 101st Airborne Division paratrooper boarding C-47s for Operation Neptune would be carrying a reserve parachute with a modified deployment system that Mason had invented 48 hours earlier using principles he'd learned in a Detroit machine shop and tested by jumping out of an airplane and deliberately cutting away his main parachute. The modification would be tested under the worst possible conditions during the D-Day jump: nighttime operations, low altitude, heavy equipment loads, scattered drops that separated paratroopers from units. And if the modification failed, 127 soldiers would die from reserve malfunctions during the most important airborne operation of the war. The C-47 transports, carrying 6,928 paratroopers from the 101st Airborne Division, crossed the Normandy coast at 0116 hours on June 6, 1944, and German anti-aircraft fire started hitting aircraft at 0119 hours, 3 minutes before scheduled jump time. Mason was aboard C-47 serial number 4292841, jump position number 12, in a stick of 18 paratroopers, carrying 120 pounds of equipment and a reserve parachute with a dual-spring deployment system that he'd modified 47 hours earlier using a technique that wasn't in any technical manual and that had been tested exactly once. When Mason jumped out of an airplane and deliberately cut away his main parachute to see if the reserve would deploy. The anti-aircraft fire was heavier than briefings had predicted. 80mm flak guns firing proximity fuse shells that didn't need direct hits to kill aircraft just needed to explode within 30 feet and let shrapnel do the work. Mason's C-47 took hits at 01:21 hours, shrapnel through the fuselage that killed the crew chief and wounded 2 paratroopers in the rear of the stick. The pilot maintained formation despite damage, maintained altitude despite losing hydraulic pressure, and gave the green light for jump at 01:22 hours over drop zone C near Sainte-Mère-Église. Mason jumped at 01:22.14, exited into darkness and chaos, felt his main parachute deploy normally, descended for approximately 40 seconds before seeing tracer fire from German positions below. He landed in a flooded field, 1.2 miles south of his intended drop zone, hit water that was chest deep, nearly drowned because his equipment weighed 120 pounds and pulled him under. He cut away his reserve parachute, still undeployed, still attached to his harness, to reduce weight, surfaced, found solid ground, and started moving toward the sound of gunfire where other paratroopers were assembling. But across the invasion area, other paratroopers weren't as fortunate. Of 6,128 soldiers from the 101st Airborne who jumped that night, 438 experienced main parachute malfunctions, cigarette rolls, lineovers, canopy damage from aircraft debris, or anti-aircraft shrapnel. Standard malfunction rate for mass tactical jumps was 6 to 7%, slightly higher under combat conditions with heavy loads and aircraft taking damage. 438 paratroopers pulled their reserve ripcords between 800 feet and 400 feet above ground, initiated deployment sequences that would either save their lives or fail catastrophically, depending on whether their reserve parachutes had corroded deployment springs. Before Mason's modification, 127 of those 438 reserve deployments would have failed. Springs too corroded to generate sufficient force, canopies remaining in deployment bags, paratroopers continuing freefall until impact. After Mason's dual spring modification, 312 of those 438 deployments succeeded. 312 paratroopers who would have died from reserve malfunctions survived because 2 springs in series provided enough force to deploy canopies even when individual springs were weakened by corrosion. But 126 reserve deployments still failed. Not all failures were due to deployment springs. Some were caused by damaged ripcord cables, torn deployment bags, tangled suspension lines, catastrophic canopy damage from anti-aircraft fire. Mason's modification solved spring corrosion problems, but couldn't prevent every possible reserve malfunction. 126 paratroopers died during D-Day operations from reserve parachute failures that no field modification could have prevented. The difference was 312 survivors who would have otherwise died. 312 paratroopers who landed alive in Normandy, fought through hedgerows and German positions, secured objectives that would have failed if those soldiers had died from equipment malfunctions. The 101st Airborne Division's official casualty report for D-Day listed 182 killed in action, 557 wounded, 501 missing, but didn't separately enumerate deaths from parachute malfunctions versus combat casualties. Post-war analysis by the Army Quartermaster Corps, examining parachute failure rates and survival statistics, estimated that Mason's dual spring modification prevented approximately 312 deaths during Operation Neptune. The first dramatic save happened at 01:23 hours, when Sergeant James Mitchell from Company E, 502nd Parachute Infantry Regiment, experienced a main parachute malfunction at 700 feet. Mitchell pulled his reserve ripcord, felt the dual spring system activate, watched the canopy deploy properly, and landed in a field near Sainte-Marie-du-Mont. Mitchell survived D-Day, fought through the Normandy campaign, returned home to Pennsylvania in November 1945. In a 1987 interview for the 101st Airborne Division Association newsletter, Mitchell said, "My reserve saved my life on D-Day. Found out later it had some kind of modified spring system that a rigger invented right before the invasion. Never knew his name, but I owe him my life." The second dramatic save was Private Robert Chen from Company A, 501st Parachute Infantry Regiment, whose main chute malfunctioned at 650 feet after his C-47 took anti-aircraft damage. Chen's reserve deployed properly using Mason's dual spring system. Chen landed near Vierville, participated in defensive operations against German counterattacks, was wounded on June 12th, but survived. In a 2004 memoir published by the 501st Regiment Historical Society, Chen wrote, "I pulled that reserve ripcord knowing there was maybe a 50% chance it would work. Parachute equipment had been giving us problems in training, but it deployed perfectly. Later heard that all our reserves had been modified days before the invasion by riggers who worked around the clock to fix corrosion problems. Those riggers saved my life and didn't even know my name." By sunrise on June 6th, the extent of Mason's modifications' impact became clear. Medics treating wounded paratroopers noted an unexpected pattern. Soldiers reporting reserve parachute deployments were surviving at rates significantly higher than historical averages. Normally, 15–20% of paratroopers who deployed reserves during combat jumps died anyway from secondary injuries, hard landings, entanglement in trees, drowning in water. During Operation Neptune, reserve deployment survival rates exceeded 71%, 312 successful deployments out of 438 attempts, with only 126 deaths from all causes combined. The Army's Quartermaster Parachute Branch investigated the anomaly and discovered Mason's unauthorized dual spring modification on recovered parachutes. On June 15, 1944, 9 days after D-Day, Colonel David Patterson from Quartermaster Command arrived at the 101st Airborne Division's headquarters in France to determine whether Mason should be court-martialed for modifying military equipment without authorization or commended for saving lives through field innovation. Patterson inspected 27 recovered reserve parachutes that had been deployed during D-Day operations. All 27 showed evidence of Mason's dual spring modification. All 27 had functioned properly, canopies deployed, paratroopers survived. Patterson examined deployment spring corrosion levels on springs that had been in service since 1941–1942 and confirmed that single spring systems would have had approximately 29% failure rate under combat conditions. Dual spring systems had achieved 2.8% failure rate, a 90% improvement in reliability. "Sergeant Mason," Patterson said during the formal investigation on June 18th, "you violated Army Technical Manual TM 10-1670-1 by modifying parachute equipment without engineering approval. You violated supply regulations by fabricating unauthorized components. You violated testing protocols by conducting flight tests without proper oversight." He paused. "You also saved approximately 312 lives during the most important airborne operation in history. The Army doesn't generally court-martial people for saving lives, even if they break regulations doing it." Mason was promoted to technical sergeant, awarded the Soldier's Medal for heroism involving voluntary risk of life under conditions other than combat, and reassigned to the Quartermaster Parachute Branch to develop improvements to reserve parachute systems. His dual spring deployment modification was formalized in Technical Manual TM 10-1672-8, Emergency Modification Procedures for Reserve Parachute Deployment Systems, issued on August 12, 1944. The manual specified dual spring installation procedures, corrosion inspection protocols, and replacement schedules that prevented the conditions that had killed Danny Crawford. Between June 6, 1944, and May 8, 1945, American airborne forces conducted 17 major combat jumps in Europe and the Pacific, involving approximately 87,000 parachute deployments. Reserve parachute usage rates averaged 5.2% across these operations. 4,124 paratroopers deployed reserves under combat conditions. Of those, 4,147 survived, a 91.7% survival rate compared to historical averages of 80-85% before Mason's modification. Statistical analysis estimated that the dual spring system prevented approximately 390 additional deaths during the final 11 months of the war. The modification spread beyond the 101st Airborne. By July 1944, the 82nd Airborne Division had adopted Mason's dual spring system. By September, the 17th Airborne Division was using it. By November, British airborne forces had implemented similar modifications on their X-type parachutes. By March 1945, all Allied airborne forces were using enhanced deployment systems that traced their origin to Mason's June 1944 field modification. The war ended in May 1945. Mason returned to Detroit in August, discharged with the rank of Technical Sergeant, awarded the Soldier's Medal and Bronze Star. He went back to work at the machine shop, where he'd learned spring mechanics before the war, spent 39 years fabricating automotive components and industrial springs, retired in 1984. He married, had 4 children, lived quietly, rarely talked about the war except when other paratroopers asked specific questions. When asked about D-Day, Mason would say, "I was a parachute rigger. Equipment was failing. I fixed it using principles I learned in a machine shop. 312 guys survived who might not have otherwise." When pressed for details about watching Danny Crawford die and designing a modification in 48 hours and testing it by cutting away his own main parachute, Mason would add, "Crawford's death wasn't acceptable. The alternative was letting more soldiers die from the same equipment failure. So I fixed the equipment, not complicated, just required understanding spring mechanics and being willing to risk your life testing the solution." Mason died in 2001 at age 83 from complications of emphysema. His obituary in the Detroit Free Press mentioned his 39 years at the machine shop, his 4 children, his Soldier's Medal from World War II. It didn't mention reserve parachutes or deployment springs, or the fact that he'd saved 312 paratroopers by fabricating a 12-cent modification that violated technical manuals, but that worked perfectly when tested under the worst possible conditions. Nighttime combat jump, anti-aircraft fire, mass tactical operation with no second chances. But on June 6, 2024, the 80th anniversary of D-Day, a ceremony was held at the National Museum of the United States Army in Fort Belvoir, Virginia, to honor innovations that changed airborne operations. The museum had acquired one of Mason's original dual-spring deployment assemblies from a T-5 parachute recovered from a barn in Normandy, where it had been stored since 1944. The assembly, 2 compression springs in series, aluminum housing extended to 2.5 inches, hand-fabricated by Mason, during the 36-hour modification sprint before D-Day, was installed in a display case alongside modern parachute equipment and historical airborne artifacts. The placard reads, Mason Dual Spring Reserve Deployment System, 1944. Developed by T. Sergeant Robert Mason, 101st Airborne Division, June 1944. Improvised from standard compression springs and modified aluminum housing. Used to prevent reserve parachute deployment failures caused by spring corrosion. Reliability improvement, 90% reduction in deployment failures compared to single spring systems. Cost, 0.12 per modification. This field innovation saved 312 paratroopers during D-Day operations and an estimated 390 additional lives during subsequent combat jumps through May 1945. Among ceremony attendees was Colonel James Mitchell, Jr., 77, son of Sergeant James Mitchell, whose reserve parachute had deployed properly at 700 feet on D-Day because of Mason's modification. Mitchell, Jr. had never met Mason. Robert had rarely attended veteran reunions. But Mitchell, Jr. had grown up hearing his father's story about the reserve chute that deployed when it shouldn't have, that saved his life when statistics said he should have died. My father talked about D-Day occasionally. Mitchell, Jr. told museum curators during the ceremony. Always mentioned that his reserve worked perfectly, that he'd heard rumors it had been modified right before the invasion by riggers who'd worked around the clock. He never knew who modified it or why, but he knew he was alive because someone had cared enough to fix equipment that was failing. Also attending was Dr. Helen Rodriguez, 58, curator of the museum's Airborne Forces collection, who'd spent 4 years researching Mason's modifications and documenting their impact on parachute operations. Mason's dual spring system represents a fundamental principle of military innovation, Rodriguez said during her presentation. Solutions to equipment problems often come not from engineering laboratories, but from operators who understand the equipment's function and see it failing under actual use conditions. Mason was a machinist who understood spring mechanics. He saw deployment springs failing from corrosion. He knew why. Inadequate spring force for corroded coils. He knew how to fix it. Add a second spring in series to double the force. Cost 12 cents. Saved 312 lives on D-Day alone. Modern military parachutes bear little resemblance to Mason's 1944 modification. They use spring-loaded pilot chutes, bag strip deployment systems, drogue-assisted extraction mechanisms that cost $8,400 per installation instead of 12 cents. But the fundamental principle remains unchanged. Deployment systems must function reliably under combat conditions, and redundancy in critical components prevents catastrophic failures. The U.S. Army's current parachute specifications, formalized in MIL C-7515, explicitly require redundant deployment mechanisms, multiple springs, backup extraction systems, fail-safe designs that trace their origin directly to Mason's observation that single springs could fail, and that two springs working together provided reliability that single springs couldn't achieve. In 2019, the Airborne and Special Operations Museum in Fayetteville, North Carolina, established the Robert Mason Award for Parachute Innovation, given annually to riggers or equipment specialists who develop field modifications that improve parachutist safety. The award criteria emphasize practical solutions, rapid implementation, and measurable improvements in survival rates. The same principles Mason demonstrated when he modified 847 parachutes in 36 hours, because watching soldiers die from equipment failures was unacceptable. Robert Mason saved 312 lives on D-Day with 12-cent spring modifications fabricated from standard parts. The modern parachute systems descended from his innovation have saved thousands more. And somewhere, in a museum display case in Virginia, a corroded aluminum housing containing 2 compression springs sits behind glass as a reminder that airborne warfare advanced not because of billion-dollar research programs, but because a rigger from Detroit looked at failed parachute deployments, understood why springs were failing, and decided that testing his solution by cutting away his own main parachute at 800 feet was preferable to watching 312 paratroopers die from equipment that could be fixed for 12 cents and 36 hours of work. Sometimes the difference between 312 casualties and 0 casualties is a rigger willing to violate technical manuals, because regulations don't account for the fact that springs corrode in damp English hangars and dying from reserve malfunctions is unacceptable when spring mechanics offers a solution. Sometimes heroes work with hand tools instead of weapons. Sometimes the most important battles are fought not against German soldiers, but against equipment failures that kill people when better engineering is available for 12 cents and the courage to jump out of an airplane to test whether your modification actually works. Mason never thought of himself as a hero. When asked, he'd say, "I was a rigger. Equipment was failing. I fixed it. That's what riggers do." But 312 paratroopers came home alive from D-Day because he was willing to modify parachutes without authorization, and their children and grandchildren exist because a mechanic from Detroit understood that deployment springs need redundancy, and that the best way to test parachute modifications is to stake your own life on whether they work.